Hello students, welcome to this session. This is the second session on normal distribution. In the first session on normal distribution, we have considered the basic definition of normal distribution, standard normal, variate, how to convert normal to standard normal, and we also some of the examples on that normal distribution. Now let us go with some more examples on normal. And the fourth example is like this. Fit a normal party curve for the following data, and the data is given as x values, that is 2, 4, 6, 8, 10, and f values 1, 4, 6, 4, 1, and these are the computed values. I'll explain later on. And the first they asked you to write the or they asked you to fit the normal party curve for the following data. Curve. The geometrical meaning of a curve is function, or the geometrical meaning of a function is curve. In order to draw the curve, we need a function. The meaning of this particular example is we have to find the normal party function corresponding to the given numerical data. And we know that the normal party function of the normal party function is given by, that is f of x equals to 1 upon root 2 pi sigma e raised to minus 1 upon 2 sigma square into x minus 1 whole square. Once you plot this function, you are going to get the normal party curve. That's why we have said here the normal party curve is given by the function f of x equals to 1 upon root 2 pi sigma e raised to minus 1 upon 2 sigma square into x minus mu whole square, where x lies between minus infinity and plus infinity. And in earlier distribution also called, in order to write the distribution or in order to write the party function completely, we must know its parameters. As we know, for normal distribution, the parameters are mu and sigma, where mu is the mean and sigma is the standard deviation. That's why using the given data, we have to compute those two quantities. One is mean and one is standard deviation. And this is the discrete frequency distribution. And for a discrete frequency distribution, the mean is given by, that is x bar equal to summation fx divided by summation f. Summation fx means you have to calculate the product of x into f and you have to add them. It will give summation fx. In this case, its value is 96, and total frequency, that is noted by capital N and is given by 16. That is 96 divided by 16 is going to be 6. That will be the first one, that is mean. And standard deviation sigma is given by, for a discrete distribution, square root of summation fx square divided by n minus summation of fx divided by summation f whole square. In order to get summation fx square, first you have to calculate fx square. Already fx is calculated. Once you multiply one more by time by x, you are going to get fx square. Once you add those values, you will get it as 640 that you have taken here. Capital N is the total frequency, that is 60, minus summation fx, that is 96, divided by summation f, that is 60, and you are required to take the square for that. And 640 divided by 16 is 40, and 96 by 16 is 6 square is 36, and here under root we get 4, square root of 4 is 2. Okay, now we got both the values mu and sigma. Once you substitute them in equation 1, we are going to get the curve in this fashion, function in this fashion, that is 1 divided by 2 root 2 pi e raised to minus 1 upon 8 x minus 6 whole square, where x lies between minus infinity and plus infinity. If we go on give different values for x, we will get the corresponding values of f of x, and once you plot that, we get the required normal party curve for the given data. That is the way how we can find the normal probability curve for the given numerical data of x along with some frequencies. Now there is one more problem, and the problem goes like this. Steel rods manufactured to be 3 centimeter in diameter, but they are accepted if they are inside the limits 2.99 and 3.01 centimeter. it is observed that 5% of the items are rejected due to oversized and 5% of the items are rejected as undersized. Assuming that the diameters are normally distributed, find the standard deviation of the diameter of the steel rods. Anyhow, first let us understand what is the problem and what we are required to calculate. Once you look at the information given or provided is regarding the diameter of the steel rods. That's why let us take the variable x as diameter of the steel rods in 3 centimeters. Generally, they said the steel rods manufactured to be 3 centimeters means the average diameter of the steel rods which are manufactured by a company must be 3 centimeter in diameter. Okay, that's why we have average diameter equal to mean, that is nothing but mu equal to 3, that is given, and standard deviation we have to compute. Okay, that's why let us take it as sigma. That's why, as they have said, diameters are normally distributed. That's why we can take x, that is diameter of the steel rods, is normally distributed with average diameter mu equal to 3 and unknown standard deviation sigma. And we can write down the standard normal variate equals to x minus mu by sigma, that is x minus 3, and since sigma is unknown, let us write it as sigma itself. And here some values are not appeared here, and this value is 3, this value is 2.99, and this value is 3.01, and they are given, actually we need the diameters to be 3 centimeters, but anyhow some tolerance is given and the diameters which are produced are accepted, okay, if they are within the limit 2.99 and 3.01, that will be the tolerance what we can set as. And again further information they have provided that 5% of the rods are rejected due to undersized and 5% of the rods are rejected due to oversized. Undersized means which are less than 2.99 centimeters. Oversized means which are greater than 3.01 centimeters in diameter. They are the criteria to say undersized and oversized. Now, according to the given information, let us write some of the facts. That the probability of rejection due to undersized, how much are rejected? 5% are rejected. That's why probability of rejection due to undersize is 5% and probability of rejection due to oversize is 5%. They have given. Now probability of, when you say that they are rejected due to undersized, whenever the diameter is less than 2.99, then we say that it is going to be rejected due to undersize. That is the criteria for the rejection due to undersize is whenever the diameter is less than 2.99, this will be the criteria to say that they are rejected due to undersize. And the probability of that rejection due to undersize is 5% means 5 by 100, that will be 0.05. Similarly, probability of rejection due to oversized. Oversized means the diameter should be more than 3.01 centimeter. That is, if probability of x is greater than 3.01, okay, is 0.5 they are given, and this will be the criteria for the rejection due to oversize. Now convert them to standard normal, subtract mean divided by standard deviation. Since standard deviation is unknown, keep that one as it is. It is equals to 0.05. Here also the same thing we did. And we don't know what is this value, but anyhow it is divided by z. Z is less than Z1 because we are not familiar with the sigma. We cannot compute. Let us denote as Z1. That is the product of Z is less than Z1 equal to 0.05, where Z1 is 2.99 minus 3. That is minus 0.01 divided by sigma. And here it is greater than Z2. Is again it is 0.05. And this will be 3.01 minus 3. That is 0.01 divided by sigma. Now we have to plot this situation. Okay. Now draw the normal curve on both sides. Okay. Somewhere z equal to 0 is at the right, left side minus 1 is right side plus values. Now the question is where we have to take z1 and where we have to take z2. Anywhere we can take z1 and z2 here, but they have to fulfill this particular probability. Suppose in the worst case, if I take at the middle, if I take z1 at the middle, less than z1, okay, here less than means below z1, how much area I'll get? I'll get 0.5, but I don't want 0.5, only I want 1. 0.05. That's why in order to meet out this, that's why I'll shift my Z1 here and I'll mark less than this is going to be 0.05. In the same fashion, if I take Z2 in the worst case at the center, greater than means above that, I'll get zero point 0.5. But I don't want zero point 0.5, but it is only equals to 0.05. That's why it has to be shifted. That's why here I'll mark somewhere Z2 and I'll write its value as 0.05. Now looking at the diagrams, we can conclude that priority between 0 and Z1 is 0.45 because left half is zero point 0.5. From that, this much is 0.05 means the remaining is 0.45. From these diagrams, we can write that probability that 0 is less than z is less than less than z1 is 0.45. That is this one. Okay, similarly, probability that 0 is less than z is less than z2 is again 0.45. Again, just look at that standard normal table, what I've shown. Now, inside the table, you have to search where is 0.45 or nearest value for 0.45. Okay, now once you can look here, its value is 0.4505 and here it is 0.4515, or we can choose these two, and here it is 0.4495 and here it is 0.4505. If I take this one, I am lagging by 5 units. If I take this one, I am leading by 5 units. Means both are equidistant from 0.45. I can choose anyone. Let us go with 1.64. That is the mean difference. That is 0, 1, 2, 3, 4. That is 1.64. Let us go for that. Okay. If I take from the normal table, if I take Z1 value as 1.64, since this Z1 is attached with the negative sign because Z1 lies left of 0. That's why the negative sign. And here again, anywhere the above that, a 0.45, the corresponding Z2 value is 1.64 only I can say. But what is your Z1? That is minus 0.01 by sigma and equals to minus 1.64. And here the Z2 is 0.01 by sigma and it is 1.64. If I cross multiply, okay, and I'll get sigma equals to, that is 0.01 divided by 1.64. Here also 0.01 divided by 1.64. Both will lead to the same answer, that sigma equals to 0.0061. Here also it is 0.0061. This is the way how to calculate the standard deviation. And only the thing, marking Z1 and Z2 is very important. Start with the worst situation, that Z1, if it is at the center, below that we get 0.5 probability. But here it is not 0.5, it is what? 0.05 means that Z1 has to be still left to that left of that 0. That's why here we have taken. In the same fashion, if I take Z1 here, Z2 here, above that I'll get 0.5, but it's not 0.5, it is 0.05. That's why that Z1, Z2 has to be shifted to the right of 0. So that choosing that value is very, very important. Now let us go with one more different kind of problem. In the previous case, only one unknown, that is sigma. In the next problem, we are going to find two unknowns, that is both we have to calculate mu and sigma with some information. Okay, they are given like this. In a normal distribution, 31% of the items are under 45 and 8% are above 64. Find mean and standard deviation of the standard deviation, given that area up to 0.5 is 0.19, area up to 1.4 is 0.42, they are given. Okay, now the information provided is regarding the value of the variable. That's why I'll say let x represents the value of the variable, and they are given in a normal distribution. That's why I say let x follows normal with both unknowns, mean as mu and the variance as standard deviation as sigma. Once we know that parameters, we can write the standard normal as z equal to, that is x minus mu by sigma. Since both are unknown, that's why at the most we can write like this. Now let us use the given information now. First one. Okay, the first information is 31% of the items are under 45, means probability that the variable x is less than 45 is 31%, and probability that the variable is greater than 64 is 8%. That is above 64 is 8%. This is the given information. As you know, these are normal. Now let us convert them to standard normal by subtracting mean and dividing by standard deviation. Since both are unknown, let us take them as mu and sigma as it is. Then this is nothing but our z that are denoted, and this value let us denote as z1, and this is 0.31 as it is. Z1 is 45 minus mu by sigma, and this one is z, and let us denote this one as z2, and greater than that will be 0.08, and z2 is 0.64 minus mu by sigma. Okay, now again, the problem is where to choose Z1 and where to choose Z2. Okay, now here the situation is anywhere you can choose Z1, the area below that Z1 is equals to 0.31. If I take at the center, below that how much I'll get? 0.5. But I am not, it is not 0.5, it is 0.3. That's why this Z1 should be left of 0 still. That's why I'll take Z1 here and I'll mark. Below this it is 0.31. When this is 0.31, the remaining between that Z1 and 0 is 0.19 because the left of course 0.1. Now coming to this one, anywhere you can choose. Okay, Z2. The area of the product is greater than the Z is greater than Z2 is 0.08. If I start with the center, if I take Z2 here, above that I'll get 0.5. But 0.5 I'm not interested, only I want 0.08. That's why it has to be shifted to right of 0 further. That's why I somewhere I'll mark here as Z2 and I'll mention this area is 0.08. When this area is 0.08, the area between 0 and Z2 is 0.42. Now let us go to the standard normal table and you identify, okay, from these two diagrams we can conclude that probability between 0 and Z1 is 0.19, probability between 0 and Z2 is 0.42. From the standard normal we get. Now we have to search where is 0.19. Okay, now let us go to the table, we search the nearest value for 0.19. 0.19. Okay, now if I take this one, I'm lagging by 21 units. If I take this one, I'm leading by 15 units. That means this one is nearer to 0.19 as compared to this. That's why the corresponding Z value is 0.5. That's why we can write Z1 equals to 0.5. Since Z1 lies at left, that's why that Z1 is along with the negative sign. Now, from the table, we have to search the nearest value for 0.42. Okay, you search the nearest value for 0.42. Okay, if we go like that, here it is 0.4192, means we are lagging by 9 units, and here we are leading by 7 units. That means this one is nearer to 0.42. Okay, 1.4, sorry, 0.42 as compared to this one. That's why I can take it as 1.41. That is the reason why we have taken that one as 1.41. Now substitute the respective values of Z1 and Z2, we get this as Z1 is here, Z2 is here. If you rewrite by cross multiplying, we get this one. Okay. Now as there are two unknowns, if you solve these two using calculators with the two unknown case, we find mu as 49.87 and sigma as 9.74 we get. And using these two simultaneous equations, by solving them we get the value of mean as 49.87 and the standard deviation as 3.74. And these are some of the practice problems we try to work out. If you find any doubts or difficulties in solving this, please contact me with this. Please contact me, and with this particular notes, I'm attaching one table that is known as standard normal table, and from this table we can read the standard normal probabilities from 0 to z, means from 0 to something, and see how to read this table, that is also very very important. Okay, try to understand. In every example I have shown how I have taken the values. Still, if you find any doubt, you are free to contact at any time. This is all about the continuous distributions, and this is all about that normal distribution. So far, we have studied two discrete distribution, binomial and Poisson, two continuous distribution, that is exponential and normal distribution. Thank you.